Good morning, students. Today we are going to discuss a few topics from chapter 9, Mechanical Properties of Solids. Now the first topic which we are going to discuss is your shear modulus of elasticity. Now what is shear modulus of elasticity? Let me define. It is defined as the ratio of the tangential stress to shear strain. Now stress is nothing but force by area. So here in this figure you see you do have a cuboid fixed on the surface. Now what we have done, you have applied a force tangentially to the top surface of the cuboid, and as a result the top surface deflects by an angle theta, but the base surface is fixed. Now the edge AF deflected by an angle theta to AF dash, and similarly BC deflected by an angle theta to BC dash. Now tangential stress is nothing but the force by area. So here tangential stress is nothing but the tangential force by area. So F is the tangential force X on the top surface, and A is the area of the face where F is applied. It means force is applied. Now shear strain is nothing but the angle deflected by the edge AF due to the application of the tangential force. So shear strain equal to theta. So as theta is very small, that's why you can consider tan theta. Now tan theta, if you consider the right angle triangle, then perpendicular is your FF dash or EE dash, whatever you consider. Here we have considered EE dash, you can consider FF dash. Perpendicular by base is your AF. So EE dash or FF dash is same, and that is nothing but is your delta X. So delta X by AF is your height of the cuboid, so delta X by L. So shear modulus is basically denotes by the symbol eta, that is your tangential stress by shear strain. So tangential stress is your F by A and shear strain is your delta X by L. So if you simplify, it comes out to be your FL A delta X. So this is your shear modulus of elasticity, and here stress is your tangential force that define the stress, and shear strain is your angle deflected by the edge due to the application of the tangential force. Now next one which we are trying to define is your bulk modulus of elasticity. So bulk modulus comes when you put an object inside liquid. So what will happen? Liquid exert pressure in all direction on the object. So let me define what is bulk modulus. It is defined as the ratio of the bulk stress to the volume strain. Now when you put the object inside the liquid, due to the pressure, the volume decreases. So initial volume is your V and the final volume is your V minus delta V due to the application of the pressure P in all direction. So bulk modulus is your what? As per the definition, bulk stress is nothing but the pressure, and pressure we know force by area. So pressure of the exerted by the liquid on the object, and volume strain is your minus delta V by V. So negative sign is due to the decrease in volume. So this is your bulk modulus of elasticity. Now next one is your Poisson's ratio. Now we know if we elongate an string, its length increases but simultaneously its area of cross section decreases. So Poisson ratio deals with the lateral strain to the longitudinal strain. So the ratio of the lateral strain to the longitudinal strain is called Poisson's ratio. So if you consider an object fixed from the rigid support of length L and diameter D, and if you put some weight at the free end of the rod or the string, what will happen? It will elongate due to the weight, and as a result length increases but diameter decreases. So Poisson's ratio is nothing but the lateral strain, that is minus delta D by D, to the longitudinal strain delta L by L. Minus sign is due to the decrease in diameter. So if you simplify, it becomes your minus L delta D and D delta L. So Poisson's ratio basically denoted by sigma. So please go through this part. This part is very important, and next class we are going to discuss a numerical as well as graph related to stress strain. So these are different kinds of modulus of elasticity based on the different kinds of stress and strain. So please go through. Next class we are going to discuss numerical based on the formula which we have defined, and also some graph related with stress and strain. So thank you.